On August 6, 1945, at 8:15 a.m., about 100,000 people would take their last breaths as they watched the atomic bomb fall ever closer to the ground, where it would detonate and destroy everything in its way. But how is this kind of power even possible? On March 14th, 1879, Albert Einstein was born in Ulm, Germany. However, his childhood was unusual, to say the least. Albert began scoring above all of his classmates in elementary school and was moved to advanced courses. He furthered his education in Switzerland and graduated with perfect scores. Albert Einstein worked as a theoretical physicist and eventually discovered the theory E equals mc squared. E equals mc squared stands for E, energy, equals mass, m, times the speed of light, c squared. This equation was and still is one of the biggest discoveries in science. But first, he started by releasing the theory of relativity, which states that space and time are not absolute, but rather relative to the observer's frame of reference. For example, sit with a pretty girl for an hour and it feels like a minute. That's relativity. From there, he added to this theory of relativity when he published the formula E equals mc squared on September 27, 1905, which, in summary, states that a small amount of mass can be stored into a lot of energy. The impact of his work was way more than Albert Einstein or anyone else could have expected. His theory drastically changed warfare, health, transportation, and the way we understand the cosmos and stars today. But not all this change was for the best. In fact, had Albert Einstein known what publishing this theory would cause, we believe that he would have never released it to the public. For the first 20 to 30 years, this formula didn't do much damage. This would all change after December 14th, 1941, when Japan launched a brutal attack on Pearl Harbor, forcing the United States to join the war against Germany and Japan. From there, the U.S. started the Manhattan Project to try and win the race against Germany and Japan to create these very dangerous weapons known as nuclear bombs. Each nation was to convert a tiny amount of mass into a massive amount of energy using E equals mc squared. Eventually, in July of 1945, about 3 years of war, the first bomb was successfully created and tested by the U.S. on a site 210 miles south of Los Alamos, New Mexico. This success was known as the Trinity test, and that led to the atomic bomb being added to the arsenal of the United States of America's Army. Later that year, 2 atomic bombs would be dropped by the United States. Little Boy was dropped over Hiroshima, and Fat Man was dropped over the city of Nagasaki. The resulting explosions immediately killed 100,000 people, poisoned another 146,000 people with nuclear radiation, and injured 100,000 more, and wiped both cities nearly off the map. 4 years later, when Russia developed their own nuclear weapons, the U.S. and Russia were locked in Cold War. That lasted 46 years. Each country didn't want to launch an attack on the other for fear of nuclear retribution. The U.S. public's fear rose with each year. To combat fears, the press began making posters to give citizens of the U.S. a false sense of security. Public schools began forcing kids to perform duck and cover drills in the case of a nuclear attack. Despite the press's numerous attempts to calm the public, fear continued to run rampant. Citizens began to take drastic measures to stay safe. One of these methods was to buy and install nuclear bunkers. These bunkers took around 3 years to install and cost anywhere from $40,000 to $120,000 each. An estimated 200,000 total shelters were built in the duration of the Cold War. If the average was $80,000 per shelter, that is about $1,600,000,000 spent on bunkers alone. However, not all the tech built due to E equals mc squared was detrimental to the health of the everyday person. The PET scan, or PET scan, wouldn't be possible without E equals mc squared. A PET scanner is a type of X-ray machine used in hospitals to detect early forms of cancer and other dangerous brain diseases. These complex machines use very tiny amounts of radioactive glucose, a type of sugar injected into the body in a vein. The machine rotates around the patient and takes pictures to see where this glucose is being used in the brain. Cells fight cancer and certain brain diseases use more glucose than regular cells. How does E equals mc squared play into this all? In essence, when the radioactive glucose hits the diseased tissue, it turns mass into energy, allowing the scanner to pinpoint the location of the diseased tissue. Another positive advancement made possible by E equals mc squared is radiation therapy. In radiation therapy, a giant machine swivels around the patient and targets malignant cells with concentrated radiation. The mechanics of radiation therapy rely heavily on E equals mc squared in that radiation changes the malignant cells into energy. That energy then excites all the cells around it, which excites the next layer of cells and the next until the energy hits the air and is released. Although quite painful, this form of treatment is known to be highly effective and has so far saved the lives of around 3 million people worldwide. Einstein's formula has also deepened our understanding of the stars because E equals mc squared essentially states that the energy and mass are interchangeable. When we look at the stars, like our sun, it's clear that they contain a large amount of mass. Based on Einstein's formula, that tells us that the mass and energy are interchangeable, and we can conclude that the sun, based on its size, also has an intense and vast amount of energy. This concept is known as nuclear fusion. In summary, because the star is super big, it is also super hot. Yet another application of E equals mc squared is space exploration. As we humans have advanced in technology and began sending more and more rockets into space, the old method of gas-powered engines became too heavy and costly. Using nuclear energy solves this problem. Nuclear-powered engines were developed and over many years, and eventually, radioisotopic and thermoelectric generators, or RTGs, were perfected. These types of nuclear engines are particularly useful in deep space exploration. One more benefit of the equation E equals mc squared is the generation of nuclear power. While extremely dangerous, it is also potentially very beneficial. Nuclear power plants create more energy while using less fossil fuels. The energy is both stable and efficient, and some see it as a way to slow down climate change. In conclusion, while E equals mc squared has provided many benefits, such as PET scans, radiation therapy, space exploration, nuclear power, and a great understanding of stars, these technological advancements do not outweigh the catastrophic dangers of nuclear warfare. Today, there are 27,000 nuclear weapons owned by countries all across the globe, each at least as powerful, if not more so, than the two dropped on Japan in World War II by the U.S. This capacity for the total annihilation of the human race is not what Albert Einstein intended. In 1947, Albert Einstein said, "I made one great mistake in my life when I signed the letter to President Roosevelt recommending that atomic bombs be made." Albert Einstein gave humanity as a whole the right to use this equation when he made it public. However, it is the responsibility of humanity to use it for good. While good has certainly come from E equals mc squared, the human race shirked the responsibility to use Albert Einstein's equation for good when the nuclear arms race began.